All right, so today we are finding zeros of degree 3 polynomials when you're given a zero. That's very important. They are giving us one to start out with. Completely different technique if you're not given a zero. All right, so given a polynomial and a factor of that polynomial, you remember in the last lesson we learned that if when you're dividing it using whether regular polynomial division or synthetic division, if you end up with a remainder of zero, then that number is a factor. All right, so they are telling us ahead of time here that the number that they're starting out with is a factor. All right, so given a polynomial and a factor, find the remaining two factors. List the zeros and write the polynomial in its factored form. All right, the zeros are what we get when we set a equation equal to zero. All right, so for example, looking at our first one, if we say x, this is our factor, right? X plus 10 equals 0. We say that x equals negative 10. All right, that's our first zero. And in fact, we're going to go ahead and write it down here, negative 10. All right. So they told us this is a factor, so we know how to find a zero. Let's do our synthetic division. Remember, our first step in synthetic division was to actually do this step. All right, find out the number on the outside. So we're going to make our big box. We're going to write down the coefficients. And if you'll notice here, we actually have a unit for each one of them. X cubed, we have an x squared, we have an x, we have a standard just plain constant. So we don't have to put in any placeholder zeros. So let's write in our coefficients. So there's a 1 in front of the x cubed, there's an 18 in front of the x squared, there's a 95 in front of the x, and then there's a 150 all by itself. We already said we're going to put our divisor is a negative 10. Putting that on the outside. All right, so bring down your first number. 1 times negative 10 is negative 10. 18 plus negative 10 leaves us with 8. 8 times negative 10 is negative 80. And 95 minus 80, or plus negative 80, if you prefer to think about it this way, gives me a positive 15. And 15 times negative 10 gives me negative 150. 150 minus 150 is 0. Remember, remainder of 0, because we already said it was a factor, and it's good to see that confirmed. All right, so then we end up with, remember this is x squared, x cubed. So our starting value is going to be a degree less than that, an exponent less than that. So x cubed, we're going to go down 1, so that's x squared. So this is 1x squared plus 8x plus 15, no remainder. All right. We need to find the remaining two factors. So the easiest way to do this actually is going to be to factor this polynomial. All right, so going back to our factoring unit here, we have a x squared here, our leading coefficient is 1. So we can directly factor this. We can use the shortcut method. So I know I'm going to have an x here and an x here. So then I am looking for two numbers that multiply to make 15, but add to make 8. And if we think about the factors of 15, I mean, we've got what? 1 and 15. 2 doesn't go into it. And then we have 3 and 5. Oh, hey, look, 3 and 5. So plus 3, plus 5. All right. And then we need to find the zeros, which means we need to set each piece equal to 0. So x plus 3 equals 0. X plus 5 equals 0. So here we have x equals negative 3 and x equals negative 5. So our zeros are negative 10, negative 3, and negative 5. F of x equals. All right. You see up here where it says f of x equals. So all we've done is we're going to move it from, let me see here, this is our second part of our instructions, write the polynomial in its factored form. Okay, so we found our three factors, right? We have the first one given to us, and then we found the other two, so we just need to write them down. So x plus 10, x plus 3, and x plus 5. All right, let's work on our next example. All right, they told us the 3x plus 2 is our answer. Is a factor, so let's set it equal to 0 so we can find our divisor. So 3x plus 2 equals 0. Subtract 2 from both sides, so 3x equals negative 2. So this is x divided by 3. So x equals negative 2/3. All right, I know it's a fraction. Don't panic. All right, remember, we also know this is our first 0. So let's write that down. So zeros is negative 2/3. This is also our first factor, so we can go ahead and write it down. 3x plus 2. All right, get one piece out of the way. All right, so this is our divisor. Let's make our synthetic division bars. So 3 in front of the x cubed, negative 4 in front of the x squared, negative 28 in front of the x, and then negative 16 is our constant. Our divisor here is negative 2/3. Bring down the 3. All right, and so here you have to remember your multiplication by fraction rules. Let's actually write this over to the side. So negative 2/3 times 3. So negative 2/3 times 3. And we multiply straight across. But also remember that whatever we have on the top, if we have the same thing on the bottom, we can cancel out. So 3's cancel out, and this literally leaves me with negative 2/1, which is negative 2. Okay, so negative 2. So negative 4 plus negative 2 gives me negative 6. Again, negative 2/3 times negative 6/1 equals, all right, and let's do this the long way this time. So negative 2 times negative 6 would be a positive 12. 3 times 1 gives me 3. 12 divided by 3 is 4. All right, negative 28 plus 4 is 24. Negative 2/3 of 24. All right, let's do this over here. Negative 2/3 times 24/1 equals what? All right, so negative 2 times 24 gives you negative 48/3. Negative 48 divided by 3 is 16. We're going to write that over here. And negative 16 plus 16 is 0. Okay, in confirmation, we ended up with a remainder of 0. So this is indeed a factor. All right, this was a degree 3. So we're going to start out with a degree 2, which means x squared. So 3x squared minus 6x plus 24. We already said remainder of 0. And then we're going to factor this. Now this one is not as nice to factor. But wait, I know, I hear you saying it. Mr. Bowen, we can't do this because last time we had a fraction, we had to divide it. You're right. You are indeed right. So let's erase this and let's actually divide it like we're supposed to. Remember, we said when we had a fraction, you have to divide everything by whatever this denominator is. So let's do it. All right, so 3 divided by 3 is 1. Negative 6 divided by 3 is negative 2. 24 divided by 3 is, sorry, and this is negative 24. So don't bring that down. Negative 24 divided by 3 is negative 8. We don't do anything with the remainder, and it's a 0 anyway, so we're good. So this becomes 1x squared minus 2x minus 8. Notice then, again, my coefficient here is 1, so I can use direct factoring using the shortcut method. I know I'm going to have an x and an x. So next I'm looking at what two numbers multiply to make negative 8, but add to make negative 2. All right, so let's look at factors of 8. So I know I've got 1 and 8. I've got 2 and 4. 3 doesn't go into it, so okay, it's got to be 2 and 4 because 1 and 8 aren't close enough together to get negative 2. So remember, when we are multiplying to get a negative number, we have to have a negative and a positive. I want my number to end up being negative when I multiply it together. So I'm going to make my bigger number negative. So I'm going to say x plus 2 and x minus 4. So those are the other two members of our factored form. We're going to go ahead and write those down. So x plus 2 and x minus 4. And now I need to find the zeros, which means I need to set each of those pieces equal to 0. So x plus 2 equals 0 and x minus 4 equals 0. I'm going to subtract 2 from both sides. So x equals negative 2. Add 4 to both sides. So x equals 4. So my other two zeros are negative 2 and 4. So my zeros for this are negative 2/3, negative 2, and 4. And my factored form is f of x equals 3x squared, 3x plus 2 times x plus 2 times x minus 4. All right, next one. A little extra complexity, but nothing too bad, all right? So given a polynomial and a zero of that polynomial, so they're not giving me the factored form at this point, they're just giving me a zero of that polynomial, find the remaining two zeros, and then list the zeros and write the polynomial in its factored form. Okay, so remember we have a zero. I apologize for the noise. My children think they're funny. All right, so we have a zero. Remember on our last ones, we found a zero from the factored form. So we're going to go backwards. All right, so have a zero. We know then that x equals 1. All right, I want x whatever. I want everything on my left-hand side to equal 0. So how do I make this 0? What do I have over here? I have a 1, and it's a positive 1. So if I subtract it from both sides, minus 1, minus 1, then I get x minus 1 equals 1 minus 1 is 0. Yes. Okay, so that's my first factor, x minus 1. Our first zero, they already told me, was 1. All right, so then we just do the same thing we've been doing. Synthetic division, we already know that this is 1 because they told us that from the beginning. Then we list our coefficients and our constant. So there's a 1 in front of my x cubed. There's a negative 3 in front of my x. Constant is a positive 2. Bring down by 1. 1 times 1 is 1. Negative 3 plus 1 gives me negative 2. Negative 2 times 1 is negative 2. 2 plus negative 2 is 0. So that's my remainder is 0. Very good. No fractions, so we don't have to worry about dividing anything by anything. So we started out with an x cubed. That makes this an x squared. That makes this an x. And then I have a 0. I've got nothing. No remainder, no anything. Wait a minute. Did any of you catch my mistake? Yes, I know there are several of you out here going, I have no idea what you did wrong. And some of you are saying, the x squared, you forgot the x squared. Yes, I did. Does everybody notice right here? I have an x cubed term, I have an x term, I did not have an x squared term, and I failed to account for that in here, which means I did this wrong. So let's fix it. Make sure that you have all of your pieces, all right? So coefficient from my x squared is a 1. I have no x squared term, so I'm going to put in a placeholder 0. Watch for those. That's very easy to miss. Then I have an x term, so that's negative 3, and then my constant term is 2. All right, so for today, anytime you're dividing, your dividend, that's this part, the thing you're dividing by, should have 4 pieces. All right, your answer, your quotient, should ideally have 3 pieces and then a remainder of 0. All right, so let's watch this. Let's make sure that we're paying attention. It's very, very easy to miss a piece. Placeholder 0 is super important. All right, our divisor is 1. So let's do this again properly. Bring down the first number. 1 times 1 is 1. 0 plus 1 is 1. Here we go with the ones again. 1 times 1 is 1. Oh, hey, a non-1, 1. Negative 3 plus 1 is 2. And not just 2, but negative 2. Negative 2 times 1 is negative 2. 2 plus negative 2 is 0. That's our remainder is 0. So then this was an x cubed. So this is x squared plus 1x minus 2 with a remainder of 0. All right, we need to factor this. X squared plus x minus 2. We have a leading coefficient of 1, so we can do our direct factoring shortcut method. So I know I have an x and an x. I need 2 numbers that multiply to make negative 2, but add to make positive 1. So what are the only 2 things that multiply to make 2? 2 and 1, right? I need one of them to be negative because this is a negative 2, but I want the bigger one to be positive because when I add them, I want to end up with a positive number. So that means the bigger one's going to be positive, the smaller one's going to be negative. So my other two factors are x plus 2 and x minus 1. Let's go ahead and write them down here. X plus 2, x minus 1. All right, then set each of these pieces equal to 0 so we can find out what our other two zeros are. Why did I write a 3? That should be a 1. All right, so x plus 2 equals 0, x minus 1 equals 0. Subtract 2 from both sides, so x equals negative 2. Add 1 to both sides, x equals 1. So my other zeros are negative 2, 2, and 1. Okay, sometimes we're going to end up with two zeros being the same. There's a fancy word for this. It's called a multiplicity. Multiplicity. All right, that's not anything I need you to worry about, okay? Don't stress about this. All right, if you end up with two zeros that are the same, not a big deal. Just write them down and move on, all right? But please do write them down, all right? Just like I do want to see actually x plus 1 and x plus 1. I want to see them both here because I need both of them to be there, all right, even though they're repeats. All right, so let's do our last example, shall we? We know that negative 3 is our 0. We want to find what that factor is. So x equals negative 3. I want this to be 0 on the right here, so I'm going to add 3 to both sides. So x plus 3 equals 0. So my first factor is x plus 3. And then let's do our division, making sure we watch for those placeholders if we need them. So in front of my x cubed, I have a 2. In front of my x squared, I have a negative 5. In front of my x, I have negative 73. Oh, this is going to be a fun one. Look at those big numbers. And then I have negative 120. All right, our 0, our divisor over here, we already said was negative 3. Let's start. So bring down our 2. Negative 3 times 2 is negative 6. Negative 5 plus negative 6 is negative 11. Negative 11 times negative 3 is a positive 33. Negative 73 plus 33 is a negative 40. Negative 40 times negative 3 is a positive 120. Negative 120 plus 120 is 0. Yay! We ended up correct. So they already told us this was a 0 and it was a factor, so we are looking for that remainder of 0. Yay! Okay, so this is a x cubed, so we're going to start out with an x squared, then an x, then our constant. All right, now this one does not play nice. You notice the 2 here? So we can't do the direct factoring shortcut method that we've been doing. So take a deep breath. We have to do AC method here. So remember how to do the AC method. That's A times C. So 2 times negative 40 is negative 80. So I need two numbers that multiply together to make negative 80, but add together to make negative 11. All right, so let's list factors of 80, shall we? So 80, we've got 1 and 80, we've got 2 and 40, we've got 4 and 20, and we have 5 and 16. Hey, 5 and 16 are probably the closest together I've got. And I need to make one of them negative because remember this is a negative 80 after all. And I want the bigger one to be negative because I want to end up with the negative 11. So if I do this, negative 16 plus 5, negative 11. Yes. Okay. So we're going to say then, remember we split up this b term using these numbers. So we're going to say 2x squared plus 5x minus 16x minus 40. Then we factor by grouping. Group those two, group these two. This is a minus sign here, so it needs the sign of the second one. All right. Then we factor out the GCF of each term. So 2x squared plus 5x. The only thing they have in common is the x. So we're factoring out an x. So it leaves me with 2x plus 5. Bring down my minus sign. What does 16x and 40 have in common? Well, the 8, right? So let's factor out an 8. So that leaves me with 2x plus 5. Factor out the GCF of each of these terms, which is 2x plus 5. So 2x plus 5. And that leaves me with x minus 8 All right, so my other two factors here are 2x plus 5 and x minus 8. And then let's set each of those pieces equal to 0. So 2x plus 5 equals 0. X minus 8 equals 0. Subtract 5 from both sides. So 2x equals negative 5. Divide by 2. So x equals negative 5 halves. That's my other 0. Negative 5 halves. I forgot to write down my first one. Negative 3. Or maybe I erased it a minute ago. And then back over here. X minus 8 equals 0. So add 8 to both sides. So x equals 8. Write down my other 0 here. All right, so we have our zeros are negative 3, negative 5 halves, and 8. And our factor form is f of x equals x plus 3 times 2x plus 5 times x minus 8. All right, that was a lot today. I recommend playing the video over or pausing it, doing an example problem on your homework, coming back. Just make sure that you've got it. This is a lot to absorb. All right, as always, if you have any questions, send me an email and I'll be happy to answer for you. Have a great day, guys, and let me know if you need anything.